So this first pic shows some of the stuff you need. It's a lot of stuff and probably cost around 200 euros. Also a lot of work, a lot more than I thought, especially when you're trying to make it yourself. I'd say it took me about 5 full days. It was also very difficult to get the stuff as David suggests, and as such most of the measurements had to be altered quite a bit as I went along. Here is the start of the process. You can see I made a jig just out of cardboard. As I couldn't get the correct rebar, the sizing all altered a bit, thus making my cardboard jig a waste of time in the end. What was most useful to me was cutting out a circular piece of cardboard, the same circumference as my pipes. This allowed me to mark on my palette where the holes should go and the correct size. I also used the rebar that goes at the top of the reactor to line up where the holes would be. The key here is that once the pipes are in place, they can eventually be tied onto the rebar at the top, and that there is no more than 12 inches distance from each hole. This ensures that no part of the compost is more than 12 inches from ambient flow. I think mine in the end was about 10 inches. Okay, this pic shows the pipes that I brought. Conveniently I was able to buy them with holes already in them. They were originally 4 meters in length, so I simply cut them down to size with a saw. The height of my bioreactor was slightly lower than David's, so I cut my pipes down slightly lower also. Just make sure that they can reach down through the holes in the pallet at the bottom and still be sticking out of a full bioreactor at the top. This is what I used to make the holes. It was 102mm, so pretty perfect. You could also use a jigsaw. The drill was a bit overkill at that size. I couldn't get hold of any rebar jigs, so I screwed a piece of wood onto the ends. A rebar jig would be a lot better though, as it would allow you to slot the sides of the reactor into the tops, keeping it into a nice circular shape. This is a rebar I had to use in the end. I couldn't get hold of anything around 2.5mm, so I had to go for 4.5mm, making it pretty super strong. To keep it in place I had to tie 1.1mm wire at each join. Okay, this is where I was checking the size of a water pipe before attaching the main one to the water supply. You can also see I cover the top of each pipe with a bit of cloth. This is really useful to stop leaves from dropping down during the fill-in process. It allows you to dump the leaves in pretty quickly rather than having to manoeuvre around the pipes each time. I tied the pipes in place with the same 1.1mm wire. I drilled a couple of holes into the size of a drain pipe and put the wire through the same holes as a string for eventually pulling the pipes out when the bioreactor is full of leaves. To make the whole structure a bit more solid, I drilled in some screws around the bottom of the bioreactor. It's quite surprising how often you lean on it, and this really adds some strength to it. Okay, these grain sacks were really useful for collecting leaves in. I think I had about 5 fullish sacks in the end, and I actually underfilled the reactor by about a third. You probably need about 8 of these 1 square meter sacks. You have to remember that the leaves greatly reduce when they are broken up, which is pretty disheartening when you first see it. I tried 2 leaf collectors for shredding and both were completely useless, lasting about 2 minutes before getting blocked up completely. In the end I just used a lawnmower, which worked very well in theory. This particular lawnmower had problems starting though, so the leaves were not as broken up as I would have liked. As such I'll probably wait a couple of months longer, probably around 7 to 8 months. I mainly used oak leaves as this was pretty much all I could find in the local area. If I was going to do it again I would try to get a greater variety. I would imagine this would result in a greater diversity of organisms also. For this reason I also used a small amount of manure. If you use a lot then the decomposition process takes up to a year, which is too long, as I want to eventually use the final product as a slurry to test on different wheat seeds. Here you can see the wetting process. I just did 1 bucket at a time and used the back of a spade to pad the leaves down to get water over all the surfaces of the leaves. Around every 5 to 10 goes I emptied the container on the floor and refilled with fresh water. It gets very dirty and there is a lot of dirt that settles to the bottom. With this shape of container it was very difficult to just scoop out as David suggests. Okay, one final shot of the reactor just before filling. It's still nice and clean at this point. As it was only 2/3 full in the end, The irrigation system is quite far down, and to ensure the pipes follow the pile of leaves as they decomposed, I weighed the pipes down a bit with a piece of wood. The main irrigation pipe is 13 millimeters. You have to make sure you have the correct water pressure here, and ideally you should be watering about 6 to 7 litres each 1 minute. I drilled 1.5 millimeter holes every 4 inches in the irrigation pipes, one facing downwards and then one facing in. I also inserted some 1/8 inch or just over 3 millimeter microtubing horizontally. To do the holes for the tubing, I used a 4 millimeter palm punch. The misters are 360-degree spot splitter spray sticks with a medium flow of 9 to 12 gallons per hour. Okay, I bought an Aqua Duo water that I set to come on for 1 minute each day around 12 o'clock in the afternoon. In the summer I will look at increasing this to 2 minutes. This is for when the temperature gets to around 100 degrees Fahrenheit. And the final reactor, hopefully safe and sound for the next 7 or so months. After 4 days I checked the temperature of the pile to make sure it was ambient and added around 100 red wiggler worms. In addition to using the final product as a slurry to apply to wheat seeds, I want to try to apply to pastures, possibly as a compost extract. Before using, I will check the compost with a microscope myself and send a sample off to be tested in more detail with machinery out of my price range. Please feel free to ask any questions below. I'll try my best to answer them. David C. Johnson also has some great videos. He's added some more recently on his YouTube channel also.